Al-Fatiha. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Right. Now we go to another type of functions. Remember that in chapter 3, we have polynomial functions and also rational functions. So polynomial parts we already finished. And now we look at the rational part, rational functions. So rational function is some sort like fractions. Examples of rational functions, which we always represent by Rx, the rational function. Example like 1 over x minus 2. These are examples of rational function. And the examples of rational function is like that 5x over x squared minus 9. These are examples of rational functions. And then if we talk about rational functions, we can say we can divide into proper or improper. We may have proper rational functions or improper rational functions. For proper rational functions, degree of denominator is less than degree numerator. So it is proper rational function when degree of numerator is less than degree of denominator. Examples of proper rational function are x equal to, let's say, x power of 3 plus 3x over x power of 4 plus 5x squared. Where you can see degree of numerator 3 less than degree of denominator 4. This is, we call it proper rational functions. We may have improper rational functions where degree of numerator is greater than or equal to the degree of denominator. So when you look at the degree of numerator greater than or maybe equal the degree of denominator, this is improper rational function. Examples is x cubed plus 2x plus 1 divided by x squared plus 1. Another examples are x is x squared plus 3x plus 4 minus 4 divided by x squared minus 2. You see that the degree of numerator greater than degree of denominator, or maybe degree of numerator equal the degree of denominator. This is improper rational function. When we talk about rational functions, can be either proper rational functions or improper rational functions. So it will lead us into what we call partial fractions. Partial fractions. Partial fraction. This is under rational function. Partial fractions. So we will decompose of one partial fractions. So we have to follow the guideline to compose one rational function. One rational functions in terms of fx over gx. This rational function, because rational function can be fx over gx. We talk about rational function. Rational function is fraction. One polynomial divided by another polynomial, it will produce one rational function. So guideline to compose that's rational function. This is rational function. This is rational function to compose in terms of partial fractions, to write in terms of partial fractions. So number one, look whether our partial fraction proper or improper. We have to check our rational function proper or improper. If improper, we have to make long divisions to make proper rational function plus with one real number. So remember that long divisions only we apply for the case that our rational function is improper. If it is already proper, no need to do long divisions. Number two, we have to factorize gx. And gx, when we factorize, maybe into we factorize into linear function or maybe repeated linear function, or maybe irreducible quadratic function. or maybe repeated irreducible quadratic function. When we factorize gx, step number 2, when we factorize, we need to factorize gx. When we factorize gx, we look gx after we factor, we will have linear functions only, or we may have repeated of linear function, or we may have irreducible quadratic function. The word irreducible here, meaning that we cannot reduce any longer, or repeated irreducible quadratic function. All this, right? These four. So the third steps to decompose, we need to apply either rule A, when we get linear function, so we have linear factors or linear factors. After we have linear factors, so fx over gx will be written a1 over p1x plus q1, a2 over p2x plus q2 plus until am over pmx over qm we apply rule A. We may apply rule B for the case of repeated linear factors, so that fx over gx will be written as a1 px plus q plus a2 px plus q square plus until am, where px plus q to the power of m. That's for the rule B. We may have rule C. Rule C we use for irreducible quadratic factors. So fx over gx is ax plus b divided by ax square plus bx plus c is quadratic. And we may have rule D. Only for the case of repeated irreducible quadratic factors. Ah, so Px fx over gx can be written as a1x plus b1 over ax squared plus bx plus c plus a2x plus b2 over ax squared plus bx plus c square plus until amx plus bm over ax squared plus bx plus c to the power of m. Yes? Have you got the books? Huh? And you got a book or what? If you have a maybe you have a photo in that book. Have you got a photo? Because I don't know whether your books consists of photo of this. To do partial fractions, decompositions of partial fractions. Have you got in the books? You can refer to the books, right? All the rules A, B, C, and D, all inside your books of the, I don't know the name. The name of the book, I think, pre-calculus, right? Mathematics for calculus. You can refer to book on page 745, I think, your books. But your book not stated as A, B, C, D. But it's little same. It's written as linear factors, repeated linear factors, irreducible quadratic factors, repeated irreducible quadratic factors. So that's the process of decompositions of round one rational functions to use partial fractions. And then step number 4 is to find the value. Step number 4 here is find the value A, B, C, etc. Some questions have D, E, F. Some questions only have A and B. That's the way of decompose of the rational functions. Decompositions of rational functions. So all this you need to remember, need to memorize. So these guidelines to decompose one rational functions. Let's say questions express x cubed minus 3x minus 4 over x cubed minus x squared plus x minus 1 in partial fraction, or we can say that decompose it into partial fractions. So we have to follow the steps of our guideline. The step number 1 is to look whether this function, this rational function, is proper or improper. Proper or improper. Improper. So what we have to do is we have to do long divisions. So long divisions, x cubed minus 3x. We have no x squared, x cubed plus 0x squared minus 3x minus 4. You divide by x cubed minus x squared plus x minus 1. So what do you have? What do you have? X cubed, the most left, divide by the most left.
1, sir.
1.
1.
So we have x cubed minus x squared plus x minus 1. You get me there? Is that we get that?
Yes.
So here is what? Your minus. What do you have?
Zero.
0.
1.
Oh, we say x squared.
X squared.
Here,
Minus 4.
here,
Minus 3.
Right, so we can rewrite this rational function x cubed minus 3x minus 4. This is rational function x cubed minus x squared plus x minus 1. This is rational function. Remember, the rational function comes from polynomials divided by polynomials. And this is Rx. Is equal to what? Equal to what?
Equal to 1, sir.
1. 1. Is it equal to 1 only?
1 x power of 2.
1 x power of 2.
1 over.
1 over. Remember that polynomial. Hopefully you still remember this. Therefore,
Uh, 1 plus our remainder.
what is our remainder?
X power of 2 minus 4x minus 3.
Over 3 x cubed minus x squared plus x minus 1.
Now, what we do have is one number, and this is rational function again. Rational function. This part. Because polynomial divided by polynomial. Remember, the rational come from one polynomial divided by polynomial. This is polynomial. And this is polynomial. Because now, from definition of polynomial, yes, they are polynomial. Polynomial general form is an x to the power of n. Now, this polynomial will form what? This polynomial divided by polynomial will form what? Form what? Polynomial divided by polynomial will form polynomial divided by another polynomial. What get after polynomial divided by polynomial?
Rational.
Rational. So we go back. We go back to the way or the methods, the guidelines of using partial fractions, right? Now we focus on this. This one, no more. Okay. We look whether this rational function proper or improper. Proper or improper?
Proper.
Proper. So that is that we need long divisions or not long or no need?
No need,
No
sir. No
need.
need.
No
No
need.
need.
So we go to step number 2. Step number 2 is factor gx. This is our gx now. We factor it. We factor, what we get is, try to factor it. Using a factorization, well, what? You factor it. You factor this without using calculator, right?
First put x square.
Ah,
First put x.
so here, when you factor, okay, when you factor, it's become what? You put x, and you factor this part. How to factor this? Seem like yesterday then.
We
X
separate.
square.
Huh?
Separate.
X square
Square. Kurungan x minus 1
x minus 1
plus
plus
x minus 1.
must have number.
1.
Must have a number to be 1. Common factor.
X minus 1.
So it is x squared plus 1, x minus 1. 9. So this one can be written as this. We focus on this. X squared minus 4x minus 3, x squared plus 1, x minus 1. Look like that. Therefore, we go to step number 3, which we need to look at after we factored gx, this gx. What we have? What we have types of the factors. Or we can say that we write x minus 1 first, and then x squared plus 1. Same. The two same. 2 times 3, same type 3 times 2, because of the commutative law. So what type of the factors we have for our fx? For our gx, this is the factor of gx. What type of factors we have for our gx? What type of factors?
Linear and quadratic.
Huh?
Is linear and quadratic.
Linear and this one what we call irreducible quadratic, not just quadratic. Because this quadratic is quadratic irreducible. Some of quadratic factor reducible. This irreducible quadratic. So we need to apply which rule? We need to apply which rule? We need to apply which rule?
Rule C, sir.
C? Why C? C is for what?
Irreducible quadratic.
Irreducible quadratic. Linear? No, linear. Because I have two factors. Linear?
A, sir.
A. So we have to apply two rules here. Rule A and also rule C. Okay. We go to rule A first. Rule A said that is equal to what? You look back at the rule A.
A1.
A1
A1 here we say A over
PX.
PX. What is P in this case? P in this case.
X.
P in this case is 1. So 1 multiplied by X. So X. Then Px 1. Look back at the rule A. What rule A say? A over Px
X plus Y. Plus G.
plus Q, right? Is that Px plus Q? Look at the rule A.
Yes,
Rule A. P1x plus Q. Q in this case is minus 1. That's rule A. Is it this? Rule A say this. This is a linear factors, right? But we still have irreducible quadratic factors. So we need to apply rule C. Rule C say that
AX plus B over AX squared.
but in our case, because we already have A, we start with B, Bx plus C. Instead of Ax over Ax plus B, because we don't want to confuse this A. A we already have for the part of the linear. So we go for irreducible quadratic, we start with B, Bx plus C over our what?
AX squared plus BX plus
So
C.
in this case, in our case, that's rule, but in our case,
X squared plus
squared
1.
plus 1. Right. So x squared minus 4x minus 3 over x minus 1 x squared plus 1 is equal to a. Now we want to make denominator same. So we only want x minus 1 and x squared plus 1 in our denominator. So what we have to do for a? What we have to do for a?
Times by x squared plus 1.
Times by x squared plus 1. For bx plus c, what we have to do?
Times by x
Times
minus
by
1.
x minus 1. So x squared minus 4x minus 3 over x minus 1 x squared plus 1 equal to ax squared plus a expansions plus bx squared minus bx plus cx minus c over x minus 1 x squared plus 1. Right. Any questions so far? So it is equal to what? The coefficients of x squared. So remember we have this x squared minus 4x minus 3 divided by x minus 1 x squared plus 1 equal to, from here go to here, right? Equal to, find the coefficients of x squared. What is the coefficient of x squared? What is the coefficients of x squared? Here.
A and B.
So A plus B plus the coefficients of x. What is the
Negative B plus C.
minus B plus C x and followed by A minus C. A minus C. You divide by x minus 1 x squared plus 1. Now we can compare, make comparisons. The coefficient of x squared. What is the coefficient of x squared then? What is the coefficient of x squared?
1.
1. So we can say that A plus B equal to 1. Then coefficients of x.
Negative 4.
Minus B plus C minus 4. Then coefficient of x to the power of 0. A minus C is minus 3. Then we go to the last steps. Last step is to find A, B, C. So in this case, A, B, C. In some more cases, maybe A, B, C, D. Or maybe A, B, C, D, E, F. But here, lucky that only up until C. But we need to find A, B, C using simultaneous equations. Find the values of A, B, C. Simultaneous equations, you will get A is -3, B 4, C 0. So we go back to this. We go back to the original. The original. This. X cubed. The question is this: x cubed minus 3x power of 4 minus 4 over x cubed minus x squared plus x minus 1 is equal to 1 plus this part. We already changed to this. Which is this part now is what? A over x minus 1 plus bx plus c over x squared plus 1. Now, and what is A? A, we found that it is -3. -3, because minus, we have to put bracket there. What is B? B, we found that it is 4. And what is C? C, we found that it is 0. So it's only 4x. So these divisions, this rational function can be written as this. This is what we call partial fraction. The process here, the original is here. The process that we get this. But do not forget number 1 there. 1 we get. How do we get number 1 there? From long division, from the beginning. Look at that. Try to look back at this. Stop the sessions today. Try to look back at this. So we have to follow those steps. Number 1 is to find the rational function is improper or proper. If it is proper, no problems. You go to factorize gx. And then after factorize gx, look at the factors. What type of factors? Either linear or repeated linear. So all those will determine what type of rule we use. Either A, B, C, D. In your books, maybe not written as A, B, C. Does not matter. Does not matter as long as that's the rule we use. Does not matter. And then do a partial fractions. The last one is to find the value of A, B, and C and substitute back. Do not forget number 1. So inshallah, will see you back on Thursday morning. With that, I close the sessions today with tasbih kifarah and surah Al-Asr.
Okay, sir.
Um,
Thank you, sir.
Okay, sir.
the